Hello, I'm Davide Molinelli, and today I present you the work entitled Do LLMs Generate Useful Test Oracles? An Empirical Study with an Unbiased Dataset. Writing test oracles is expensive and error-prone. While LLM shows promise for oracle generation, previous studies evaluate LLMs on public benchmarks such as the FX4Js, which are likely part of the training dataset. This data leakage inflate performance estimate, undermining the validity of the results. Prior studies also failed to analyze prompt engineering, how different code context information affect oracle quality. Finally, the impact of model size and training variance remain unclear. We don't know whether general purpose models, code specialized variants, instruction-based models, or reasoning variants perform differently. Our solution addresses these challenges with a reusable benchmarking approach. We eliminate data leakage using a fresh unbiased dataset with test case created after LLM training cutoff dates. We systematically analyze different prompts with varying code context, and we evaluate diverse model families across multiple sizes to clarify which model properties actually matter for oracle generation. As a first contribution, we propose a reusable methodology to build unbiased benchmarks. We select a proper set of 135 popular, well-maintained Java projects with strict criteria that ensure data quality and eliminate data leakage risks. From these 135 repositories, we extracted almost 14,000 pairs of test prefixes and target oracles, created after the cutoff date. We treated each assertion as a separate data point with its own test prefix. The test prefix includes all code preceding the target oracles, including any earlier assertion in the test case. As an example, a test method having 3 separate assertions contributes to 3 distinct data points. The first one following the original test prefix. The second one containing the original test prefix and the first assertion. The third one containing the original test prefix and the previous 2 assertions. This dataset building process enables us to evaluate both single and multi-assertion generation. That is a common case in real test case generation scenarios. We investigate the impact of the information in the prompt, designing 4 increasingly informative templates containing the test prefix and the source code of all the methods invoked within the prefix. These represent our minimal baseline. The baseline plus the methods and the fields defined within the test class. The baseline plus the methods and the fields defined in the focal class, that is the class under test. And finally, the baselines plus all the information from both the test class and the focal class. These 4 configurations allow us to challenge the common assumption that more code context is better in test oracle generation. We evaluate the impact of the size and type of LLMs in generating oracles, including in the experiment 10 LLMs across 3 different families, Queen, Phi, and Llama. We varied both the scale from 1.5 billion to 70 billion parameters and the training specialization, considering general purpose model, code specialized variants, reasoning models, and instruction-based versions. The experimental setup generated more than 500 million LLM queries, considering all the combination of the 14,000 oracles in the ground truth dataset multiplied by the 4 prompt templates and the 10 models. Our main findings reveals that performance is proportional to model size, regardless of the training type. As model size increases from 1.5 billion to 32 billion parameters, oracle inclusion accuracy increased tenfold, from 3 to nearly 30%. Surprisingly, general purpose models perform comparably to code-specialized models. This contradicts the intuition that code-specific training is essential for coding tasks. The second key result shows that enriching prompt with the information from focal and test class provides almost no improvement over the baseline prompt, including only the test prefix and the definition of the invoked methods. To validate the effectiveness of the generated oracles, we performed mutation analysis on a sample of 4 projects. We considered 4 different test suite configurations. Test suite with test cases including only the developer-written oracles, test suite with test prefixes without oracles, test suite with test cases including only the LLM-generated oracles, and finally, test suite with test cases including both the LLM-generated oracles combined with the developer-written oracles. The test suite comprising LLM-generated oracles achieve 43% of mutation score on average, compared to the 45% for developer-written oracles, showing comparable performance. When combined with developer-written oracles, the mutation score improves to 50%, showing that LLMs-generated oracles complement existing test suites. In conclusion, LLMs can generate test oracles with effectiveness comparable to human developers. Model size leads to performance improvement, while training specialization and prompt engineering matter far less than expected. Our reusable benchmarking methodology eliminates data leakage risks and provides a reusable approach for practitioners and researchers. Thank you.